Hey everybody, this is the fifth polynomial video. This is greatest common factoring. So if you remember, factors are when we pull apart a polynomial, they're things you multiply together. So for example, 6 times 2 is 12, 6 and 2 are factors, okay? And I'll refer you to this chart over here. The first thing you want to do when you get to a polynomial you need to factor is you need to try to do the GCF, all right? And so it is probably the most important. It is the most important factoring you'll do. Okay, so your learning target today is I can factor polynomials by GCF. You can factor binomials, trinomials, fourth degree polynomials, not degree, four-term polynomials, five-term polynomials. You can factor anything with GCF as long as it is a polynomial. And GCF is greatest common factor, so it's the biggest of the factors of the integers, and then also of the exponents. We're going to go over that, okay? So the way you do this is you find the common factor between the terms, both the integers and the variables, and then you divide that out and rewrite the expression. The way it's going to look is the GCF is going to be first outside the parentheses, and then there's going to be the new expression after you divide everything out, after you divide out the GCF in parentheses beside it. Okay, so let's start right here. For this one, we have 5 and x minus 7 is equal to 5x minus 35. This is the factored form. The factors are 5, and you multiply that by x minus 7. Okay, and the product is 5x minus 35, and that the product is just when you multiply, right? So if you distribute the 5, you get 5x minus 35. And then same thing right here, you'll see that this is the factored form. So the factors are 3x, that's what could be the GCF. And then the other factor is x plus 9. Okay, and you kind of see the pattern. When you take out a GCF, you always have two factors. So the first factor is the GCF, and the second factor is the expression. Okay. All right, let's keep going. Okay, find the largest integer that will divide all the terms, and the keyword here is integer. So if you remember integer, the integer is the number, so it's the number. So 9 and 45, 9, both 9 and 45 are divisible by 9. 7 and 21, 7, and you'll see, you know, sometimes it is the smallest of the number. And then 18 and 12. Now, the smaller number is 12, but you can't divide 18 by 12 and get, you know, an integer. So 6 is actually going to be the GCF. And then right here, 15, 25, and 55, it looks like the biggest GCF is 5. Okay, well, what about the degree of the x? Like, so I'm going to write the integer. 9 is the integer, and then you see an x here and no x here. And so if they both don't have x, then you can't pull an x out for the GCF. Here there are x's. There's 2 x's right here, and there's x right here. And so that's the integer 7, but then you can also take out an x, and that's your GCF, 7x. And so when you make your expression, you'll have just a single x. Notice 7x times x is x squared. And then over here, you'll have 3 because 7x times 3 is 21. Okay, so over here, x to the third is what you can pull out, and over here, x is what you can pull out. And notice it's always the smallest. So this is the smallest. This is the smallest is 1, and the smallest is 1. And here, this would be like x to the 0. So, I mean, the smallest would be 0, which is just 1. Okay, let's keep going. Factor the polynomials. So here we go. I'm going to factor these. And it looks like this is already what we did up there. So this would be 9. That's the integer. and what's left is x plus 5. And that's factored. So if you multiplied, if you distributed 9 back in, you would get the original polynomial. Okay, here we said it's 7x. And now if we divided 7x squared by 7x, you just have an x left over. And then there's a minus right here, so it's going to be minus. And then 21x would be 3, is what we said. And remember, you can check if you distribute out that 7x back inside the expression, then you'll get the original. So definitely take time to check your work. 18 and 12, we said it's 6 and then x to the third because you have 3 x's right here. And 18 divided by 6 is 3, and we have 3 x's on the outside, so how many do we need on the inside? We need 3 more to get to 6. And this plus is this plus right here. And then 12, how many 6's are in 12? It's 2. And since we pulled out 3, we don't need to put anything back inside. All right, so here's 3 parts, which again, you can GCF out any polynomial. 15, 25, and 55 is 5. And then x is the smallest. So you have 5 times what is 15? So we have 3, and we need 2 more x's. Minus, that's this minus 5. How many times does 5 go into 25? 5. And then we have 1 x on the outside. We're trying to get to 2, so we need 1 more. And then now plus, because plus. And then 5. How many 5's in 55? That's 11. And I have 1 x on the outside. I don't need to add any more. So that's GCF factored, okay? All right, maybe we'll do a couple more. Let's see. How about we do number 20 and then 26? Okay, so between 20 and 44. So what I'm going to do is, in my mind, is I'm going to chunk it. I'm going to do the integer first. So between 20 and 44, I know 2 would work. But also, I need to go beyond, because if I put 2, there's a bigger factor, common factor, and I'm looking for the biggest. So 4 is actually going to be the biggest one. And then looks like they both have an x term. So this would be 5x plus 11, just that. Now, one way you can check is if the expression on the inside still has a GCF, then obviously you didn't get the greatest common factor. There should be nothing in common between any of the coefficients on the inside. And if all of your terms on the inside, inside this factor have x's, then well, you have another x to pull out, okay? And then 26. This is a case, oh, I want to do 23 too, yeah. So just one at a time. 3, 15, that's 3. X to the fourth, x to the third, that's x to the third. And y squared, y cubed, the smallest one is squared. Oh boy, look at this one. Okay, so I have 3 pulled out, and I don't need to write 1. It is 1. 3 times 1 is 3, so it's 1, but I don't need it. I need 4, and I've got 3, so I need to add an x. And I've got 2. I need 2, and I have 2, so I don't need a y. So 3 times what is 15 is 5. And then I have 3 x's, so I don't need any more, but I only have 2 y's, so I need to get 1 more y in there. And there you go. Okay, on this one, it is really helpful if your expression on the GCF is on factored form is not negative. So if this leading term is negative, I'm going to factor out a -1. And then I'm also going to look to see if there's an integer, and in this case it's 2. And it looks like all 3 of them have m's, so I need the lowest. The lowest is just to the first power. So now this is negative. So even though this term up here is negative, this is going to be positive, right? Because a negative times a positive is a negative. And then this is positive, but I'm multiplying by a negative when I put it in. So in other words, I pulled out a -1 out of this, so it's going to turn into a negative. And this would be 7, because 2 times 7 is 14. And then I need one more m. And then remember, this is negative, but I pulled out that negative, so now it's positive. And this is going to be 3, and I already have that m right there. So beautiful. Okay. All right. I think that's it. Always look for the GCF first. Whenever you're told to factor something, always, 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 always do the GCF first. If you're ever stuck with, if I say, factor this thing and you don't know what to do, GCF.